Okay, so in the last class, I think we have talked about the uh, training data set, testing data sets, and all about the training phase, testing phase, all the formulas and all. Like I could see. Okay, so today we are going to do some kind of models using some regression techniques, like for the linear and the logistic one. All right. For that, the first thing, what is that we have discussed, right? In the machine learning, what are the major important things? What are the process we go on in machine learning, right? Exactly. There are six process. I have been talking about that from the last class, I think, right? Like first you define your objective, then you gather your data, then you explore that, and you can say then you build some models. You go for evaluating those models, and then you predict it, and it's like what are the six steps we can call it as, right? So for if we write it as machine learning process, so whatever I said, like first you go with defining your objective, then you go for data gathering, then there comes the data exploration, then you can say model building, model evaluation, and at the last you can say model prediction. So these are the steps, basically six steps which we go on for any kind of machine learning process, for any method, any algorithm we are using. Okay, fine. Then there are some packages, like we have imported some packages over here, starting like pandas, seaborns, and the matplotlib. Similar to this, when we work on the regression techniques, we need to import some three more important topics, or you say the package that is important for that, right? So, like, what are those packages and what are those classes or the functions I'm talking about? Like, from sklearn, which is going to be used in machine learning, probably, right? From the linear model, from the sklearn, right? So you have to import, right, whatever you are going to use. Like, if you are using the linear regression, use linear regression. If you are using logistic regression, right, logistic regression. Make sure you are not giving any gaps in between them. Okay. Alright, similar this you can take from sklearn dot metrics. So these are the important one which, like, you must be needing this all, right, anytime whenever you work with machine learning. Classification report, then you go for confusion matrix. I think we discussed this on the Thursday, but many of you were not present in that class. Classification, confusion, accuracy, that's fine. And then you'll also have to write down something for splitting up your data, right? Because you would be training your data sets. So for training, you need some training data set and some testing data set. Then only you can go with that process of training phase and the testing phase. For that, you need something that could split your data, right? So it could split your data from a given range, or like from a given interval, or like with a given value. Okay, so for that, what you will have to write that from sklearn dot the model selection, you have to import the train test split. So these are the three things which are like very important. You can say package. or the functions, right? So sklearns being the package and the rest of being the function over there will be working much better, right? If you like, but so whenever you work for the machine learning, whenever you make a notebook over there, right, this 3 and this 3 over there, so it will work like better. All right, this could work better there. Now, so how does it work? First of all, right, let's run this. Okay, so we have a data set for iris, right? So what is our goal here in this data set? What's the goal? What is the major thing we are going to focus on this data set to predict the species, right? To predict the species. So that's the purpose, that's the goal, objective of my model, right? I don't have to gather the data because data is over there, right? So there is no such thing for data gathering and all. Yeah, I can go for data exploration here, right? And then I'll go for building model and then the model evaluation and model prediction, right? So this is a model of a logistic regression. Let's go with this and understand how it works, right? So I think data exploration part is not very much important for you all because exploration, or you can say the analysis part you have done, right? You know better, right? How to go with the graphs and all, like with the visualization parts, but still we'll go for that. All right. So let's start with the defining objective. You can say classify is better. So this is the first objective. Okay, right? So classify the species. If iris flower given like on the basis of their length and width, on the petal and sepal length and width accordingly by the user. So whatever the user gives, you have to define. You have to classify the species of that particular flower, right? Okay. So objective has been done, right? Data gathering is like you first have to come up with what are the features you would be working with. Features, you know, right? Which what are the columns you would be working with? That's it. Okay. Like yeah. So if this is a column or a sheet of having 4 columns, oh, if this is a sheet having such like columns over there. So if this is 1, this is 2, this is 3, this is 4, this is 5. So to which column we are going to give the more like the coefficient value, you can say, right? Because we write equations as y equals to mx plus c, or y equals to alpha naught plus alpha 1 x1 plus alpha 2 x2 plus dot dot dot. So what are these alpha? What these are going, or like what are going to be my attributes if I'm taking more than one attribute then?
Sir,
So yeah,
so your screen is still. It's
Sorry.
not.
Okay, 1 minute.
It's reconnected.
1 minute. 1 minute. It's okay now.
Yes, sir.
All right. So like I was talking about that this could be the equation, and like in the linear regression, these are the kind of the equation formed. So this is to be determined, right? So that is, these are basically the m value you can say on, that is going to be the slope or the value what we give. If I write m value as if I write the equations as uh, 2 plus zero point 0.5 x, the value of m is zero point 0.5, right? So I can say that, yeah, m is positive, and it can write similarly the things accordingly, right? So that is to be predicted basically, right? So these are 1 2 3 4 5. So whatever the m value is there, right? So in logistic or in linear, let's talk about, there could be more than one features, and this could have even like if this is 0.5x1, this is 3x2, this is 7x3, let's say this is 0x4. So which feature is important? 7 1, right? So seventh column or whatever I would taking 0 1 2 3, third column is important for me. I like that respectively the things. Okay, right? All right, fine. So similarly, like, so we have seen up that these are the columns. That is called as like you have been gathering your feature. So in this data, exactly what are my features? All four criteria are my features, because on the basis of all four we are going to just predict up these species, right? So here we'll write for data gathering, and we'll write features as test, right? So these are going to be my features basically. Sorry, this one, right? Because excluding the minus one, right? That is the last one. So I'm not going to include the species because that is not going to be my feature. That is going to be my output on the basis of these features, what we have got, right? You can add something over there and you can define what exactly you want to. Frame as nothing. Oops. Alright, so you have to define, like the objective is to determine set of the vesicular or virginica, that's it, right? So you have gathered your data, that is on the basis of these four features you are going to predict your data, right? Then what is the third step? Exploration of your data. I'm not going to do much for the exploration. You can better do this in your free time. Okay, so working with data exploration, right? This very first thing is to find up whenever you come with the exploration part. The very first thing is find. No null values, that is clear, right? This is nice. All right. So next you can look on for the data types. All right. So everything is the float, and the last one is in the object, which is going to be predicted. So it is easy, right? Then you can look on that what is the shape of your data and all the same. Okay, I'm not going to do those stuffs. You can go with this all, right? Okay, I'm going with the next process, that is building the model. And directly switching in that. Now, so when you make a model, what's important? The things whatever you have discussed in the previous three major role, right? So that is important. That the data exploration is important. So when you get understand about the data, what is being done there and what could be done there, so that becomes important, right? So that's why these three features are very important. So data exploration is very easy, right? In the model building, the very first thing is to write, because you know what there is in data, so you don't have too much waste your time. So what good thing you do directly, you select your data species, select your training and testing things, right? You discriminate between those things. So x is going to be df of iris, and what is going to be x? So you must be having some two parameters, x and y, you know, the equations, right? Y should be something equals to multiplied anything with that, right? So x would be the features on which we will be working, that is this. So these are going to be my features, and so does y. See the things. See what I can see. A sample of something like it is going to be like from 80 to 27. Anything, because sample could give you any random number, right? That is priority. Okay, fine. Similarly, if you look on for y dot head a sample, I'm getting set of was gonna see both of them values are not same. 58, 27, 11, 61. That's a difference between sample and all. I guess you know about these things, right? Okay. Now, so splitting our data set now, right? So we have discussed what is X train, what is X test, what is Y train, what is Y test. Okay. We discussed in the previous class what are those things. So now we are going to just write or declare what is X test, what should be X uh, train and all, right? So let's write about this. Okay. Sorry, this could be test. So this is going to be train test split and split x and y. That's it. Then you write that I want to give my test size by 0.33, let's say. Okay, 33% of your data will be taken as a test size, and you want your data to learn for once. So it is once your data will be circulated throughout the things, right? Okay. Now if you want to see what is the difference when you write up those things, the training, splitting and all. So I could see that I'm going to train up with 100 data and now test with 50 data. Total I was having 150, right? Okay. Similar, after training and testing, after defining these things, when you look onto X-ray, not even giving now the sample, only here, you could get probability some mixed results. What I am getting 39, 36. Okay. All right. Like for the what to say, for the sample, what we did there, right? What we are getting, any random value or any sample value for any of the row, right? Similarly, whenever you split your data and then when you use the things, this is not like you will have to only write up the sample and then you'll be getting something in unarranged manner. You can even get in the heads and all, like, because there the data is being shuffled once. Okay, so data is being shuffled. Okay, I think someone has asked some question. It's Diksha. Okay. Alright, she's asking what is the use of random state. Okay. So, see Diksha, random state is just used like random numbers. Okay, that is like how your row, or like how your column, not exactly the columns, your rows, how your rows are going to be shuffled. The values of the rows are going to be shuffled. See, I'm getting there 39, 36. So, how this game, how many times the values is being shuffled there, like at what percent it is being shuffled. That's the thing, and this ensures, this random state ensures that um, the random numbers are generated in the same order, right? Whatever the random things are, because see, whenever we generate a random number, it is not like it is same or it is in a pattern or it is in a series, right? These are not same. But when you work with this random state, the random numbers, whatever it comes in the series. Okay, that's the thing. So I think that is clear to you, right? So whatever the library we are using or the package, you can say scikit-learn. This uses random permutations to just generate the splits, and then you can get it there as the training and the testing data. Someone is coming. Okay, right. So once you have like seen your, right, the trainings and all, right. So let's look on to the testing size. See, now it was 3936 and it became 1498. Not it became, there is another data, right? That the data of 18th and 48, whatever it is. Okay, right? That is the thing. Okay, so now let's make it further. So we have completed the exploration part. We have completed the model building, right? No, sorry, we are in the stage of model building. So now what you have to do is you have to give a name to your model. Let's say this is IR. Okay, we pass this function to this logistic regression and that would be done. And after passing this, what you have to do is you have to fit your model, the features in the model, that is x and y.
So,
Yes.
can you please explain it again, the difference between logistic and linear regression?
Okay, sure. We'll do 1 minute. Alright. 1 second. Okay, fine. See what happens in the logistic, in the linear. Let me show the graphs. So these are the two graphs. You have some points over here. Say these are the points, right? So in linear regression, let's say this is LIR, okay, and this is LOR. So in linear regression, what happens? As I said, the values here you get are continuous in nature. So it might be like working starting from here. It might be starting from here itself. So this will be like kind of a straight line. You can say, right, whether it would be positive or negative, and it will be continuous in nature, right, and it will be giving you the values, right. So in case of logistic, what happens, there is no such straight lines and all, right. There is something, a graph, which is called as a sigmoid graph, like this. Why there is a sigmoid graph? Because in logistic regression you only predict the categorical things. Categorical, that means that only either true, either false, right, that kind of things. Either true, either false, either yes or either no. That's the thing. So in LIR, linear regression, that's it is a straight line passed through the. Yes, anyone could answer? The nearest points, right? It passed to the nearest points of the data points. You can say data observations. In case of LOR, logistic regression, what happens? The values could not be there, right. In the logistic one, what happens, as I say, that it is only true and false, that it means there are only point that is zero, either zero or either one. So points would be obviously lying between the only, not between the 0 and 1. It will be always lying between, sorry, only on the 0 or either 1. That's it, right. So how do we classify the things like over 0, over 1? 1 minute. How we are going to classify it, that if it is 0 or if it is 1? How? So we'll give a threshold. We'll set a threshold to this. Okay. So what this threshold does? So this will make probably a, you can say, a marginal value. A marginal value, it will take it there, right? So like if the value is coming from greater than 0, it will be taking it in the one side. So 1 point would be there. If it is less than 0, then obviously it is going to, sorry, less than 0 point something, whatever the marginal value you are giving it, like MV. So if it is greater than MV, then it will be going in one side. If it is less than MV, coming in the 0 side. So that's how we make it a graph. And then it comes with a sigmoid graph, and that looks like something this. So obviously the values are ranging from the 0 and the 1. So you find the values only at this area or this area. That's it. No middle values, because in linear regression, the values coming here could not be taken because that would be a straight graph. So how you are going to take all those values? And that would be much far like apart from the points. Okay, that's the difference between the logistic and null. I think that is clear.
Yes, sir.
All right. So once you have made your model, once you have fit your things in the model, so you are going to take your predictions now. So my model name is IR. Okay, so before predictions, what should we do is we should go for the. All right, let it be there only to write of the things run. So we would be predicting the X test, and then as I said, evaluation to be done. So for the evaluation, you would have to look onto the classification report of predictions, or you can say the Y test, whatever the original values are there, as I said, over the predictions. And that's done. Okay. So let's see predictions. So predictions values are something like this, right? What is the value of Y test? So I think approximately correct, right? Approximately, not exactly, but something might be wrong or something might be correct. It depends on the things. Okay, fine. So if this is an array, I think this could be also an array. KLP is not there. So white test is there. Okay, let's run this. So see, I've got some false and the true results. So wherever it is true would be the thing accordingly, and the false would be different. Also, it is in like in some kind of like orders, so it not be always correct one, right? So what we can see from our classification report, let's see the accuracy score of ours. I think it would work like if I write. Right, so cool. That is 98% score, right? 98% correct data would be predicted, and like it's due to the minimal of the data whatever we have. So we can take the coefficient, the intercept, Okay, now you can predict the things, right? So see, what are the features? What are your features? You have sepal length, sepal pit, petal length, and petal width. So let's write up these points, or like for any random values. Let's write this. And let's see the species, that is virginica, right? So similarly, you can spread up the thing accordingly. So in your drive, I think you are having a tightening data set. Load that and do 3 explorations and respond quickly. You have 5 minutes time. Load that tightening data set. Do 3 exploration and respond here quickly. Drive link. CYF is showing you the coefficient. Okay. Drive link. Someone is asking again. All right, you have the drive link. It's quick. Do explorations quickly. So you can take from the drive, even from the Seaborn too. Right? If you want from the Seaborn, you can take from there. df of t dft equals let's say dt. Titanic so this is like the Titanic dataset working, right? So I said you to go on and explore something in the dataset with this one or like load from your. Why I said to load from the drive, because in the drive you have a lot of features. These are having a very less features, right? But the data you're having in the drive is having a lot of features. So from there you can go like with which feature you want to classify your objective. So here my objective is to predict the survival, not to classify anything. Here I have to predict the survival. So see, here I can only have two values. That is, either the person or the passenger is going to survive, or like else it is not going to survive. That's it, right? The conclusion would be only in the one or in the zero, right? So exploration, I believe that you can do. It's easy, like going with the like how many passengers are there, or how many passengers are of the first class, how many passengers are from Southampton. Okay, anyone could answer how we can find out that how many passengers are from Southampton?
By df dot where and back down is equals to Southampton.
uh, df dot where.
Sorry, np dot where.
np dot where. Any other method? That is correct method. Okay.
df and then df in square brackets and back down and then equals to um, Southampton.
Okay. Okay, that's right. That is also right. Any different method? We have done right with a very short method. Well, these are quite lengthy. If we go for df embarked down, sorry, this is dt, and then we go for we get some true and false. And to convert this in list, right? Then to count the occurrence of true, 644, right? Instead doing this, if I only write, anyone have any other method still? Right? Go with the short things. Why to make it ladder? If you have options which could make the things in a very shorter way, why to go with the longer things? Right? So there we can go with the a bathtub. Alright, moving next to the right. So I think you can go with the visualization things and all, right? So we will directly go with the modeling parts. We'll only have to focus on the modeling parts. Alright. So the important features whenever you work with the logistic regression, the very important things is to categorize your features. That means will have to convert your features into a discrete value, either true or either false. So what are the features which would be important when I'll be looking for a survival of any person, any passenger? So all the values, all the features which are not important, I'll be going to remove all those things, right? So before going with that, let's make some discrete values for every columns, like which are necessary for us, right? So in the sex column, instead of male and female, I'll be making it as 1 or 0. 1 for male, 0 for female. So I'll be saying that get the dummy values of what? Of dt of sex column, right? And then like I'm dropping the first column. You'll be getting two columns basically. So I'm getting the, because when you say it, okay, let me show you. You'll be confused. See, you'll be getting two columns, male and female, right? So with one only I can identify that whether it is male or female, right? So I'll be writing it like this. So I will be only getting male, okay, right? Similarly, I'll be taking all those columns which are necessary for me, and then we'll be making it the embarked. So in the embarked down, or in the embarked, you can say, I think it's embarked over there. Yeah, embarked is there. So embarked, someone is there. Similarly, for the class, let's say CL, right? And then let's say this is going to be our new data frame T. Let's say even the DT, and concatenating the data now. Our next is 1. So now you can see survived, I can see concatenation and all such things. One second, one second. Oops. Survived classic, say sibling parts, where and back class, you take and back down. Alone, QS, second, third, QS, QS, second, third, QS. Okay, fine. Let's do one thing. Let's drop the unwanted features, whatever we have. So I'm going to drop because I have 6 columns. I'm not going to make it there. I'm going to drop this all. And I would say better to keep the in place value. Right, and then I'll be looking onto this sample. So these are the features for now, right? So let's drop more of the things. What should be dropped now? One, two, three, 1, 2, 3, 4. Let's just drop and let's see. So let's say these are the features, right? It's not exactly this because you also have to work on the second feature like the Q and S and all those things, right? So you can go with that. So what's today your work is to make a model, right? On the basis of this, whatever we have made, right? So I'll be uploading this one there, the drive. So on the basis of this,